Okay, so the purpose of this video is going to be to show sort of a cool verification of something we know geometrically and how it aligns nicely with what we know about something called spherical coordinates in the 3D world. So let's just remind ourselves quickly, for spherical coordinates, they're a way of locating points in the 3D world. And let's see, we have a point up here. That point would have a distance back to the origin, which we call rho. This point would also have a shadow that it makes down into the XY plane. And there'd be an angle that shadow would have with the x-axis that we call theta. And then finally, there is another angle down from the z-axis called phi. So points in this spherical coordinate system are usually written rho, theta, and phi. That's how we locate spots. We've shown in another video of mine that x is equal to rho sine phi cosine theta. Y is equal to rho sine phi sine of theta. And z is equal to rho cosine phi. Okay, so let's go look at something that you've probably heard about before. It's called the 3D Pythagorean theorem. And it's nice to talk about when you're looking at spherical coordinates, because this rho is this distance back to the origin. So let's draw in rho here. We're coming out here at some point. This distance is rho. Rho, this line segment would have a shadow that it makes down into the XY plane. I'm just going to call that R. Why not? And then also, there's a distance over here and a distance down here, which makes sense to call this X, call this Y, and call this vertical distance Z. So let's see what we know. If we were to look at the triangle on the top there that has R, Z, and rho in it, we can make a Pythagorean theorem out of that, where it's going to be R squared plus Z squared equals rho squared. If we look at the right triangle that has X, Y, and R in it, there's a right triangle lying in the XY plane. Let's see how I'll trace it out with a dotted pink line there. So from that triangle, we would have that x squared plus y squared is equal to r squared. But that's sort of cool, because this thing can get subbed right in for the r squared there. And we end up with x squared plus y squared plus z squared equals rho squared. So what I'd like to do now is take this 3D Pythagorean theorem in conjunction with the previously proved way of converting between rectangular coordinates and spherical coordinates, and show that these two things sort of agree with each other by doing a little bit of algebra. So here we go. We're going to have x squared plus y squared plus z squared equals rho squared. And let's plug some things in here. So this is going to be rho sine phi cosine theta squared plus rho sine phi sine theta squared plus rho cosine phi squared. Okay, and supposedly this whole thing that we wrote in red here should turn out to be rho squared when we're done. So it'll be neat to see if that actually happens. Let's keep going. So here, this is going to be rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta plus rho squared cosine phi. All right, so continuing, I'm just going to focus on the first two terms of this expression because they have a common factor, which I'm going to take out. So I'm going to rho squared sine squared phi times cosine squared theta plus sine squared theta. And a little alarm should go off in your mind there because you know that this piece is equal to 1. So now I will take this and this and make an expression out of it. So we end up with rho squared sine squared phi plus rho squared cosine squared phi, which you probably see the result already. Let's factor out rho squared. And it gets multiplied by sine squared phi plus cosine squared phi, which we also know is equal to 1. And when you know it, you get rho squared. So it's just neat to see how this very complicated looking way of converting between these two coordinate systems is consistent with a very simple geometric premise, this 3D Pythagorean theorem. And it's sort of neat, and it gives a little thought maybe. These things here, this cosine squared plus sine squared theta equals 1, and here it is again. That's referred to as a Pythagorean identity. So it's sort of neat how this all ties together. Okay, so I hope you enjoyed that.